Together, we created the Watt Box. Our goal with the Watt Box is to harness energy that is produced when food decays and use it to create a clean energy source that is versatile enough for our ever-changing world. We started our project with a simple question: why do foods break down over time? We quickly started researching why and how food breaks down and came away with a few main points. Food produces methane as it breaks down. The archaea responsible for this is methanobacterium, and the food decays at an exponential rate. Using this information, we start searching for ways that methane could be converted into usable energy, ultimately setting on methane pyrolysis. This process converts methane into hydrogen in a simple method. A reactor is supplied with the methane gas. The methane is heated to 600 to 800 degrees Celsius with the help of a cobalt or carbon-based catalyst. The methane is then broken down into hydrogen and solid carbon. Solid carbon is separated from the hydrogen and removed from the reaction chamber, while the hydrogen is extracted and sent to hydrogen fuel cells to be converted into electricity. Now that we understand the process behind converting methane to usable energy, let's jump to our next topic, which is our experiment. We decided to build an airtight decomposition test bench, which contained the following components: an MQ2 flammable gas sensor, which was calibrated to measure methane levels, a BME280 temperature, humidity, and pressure sensor to monitor the environment inside the test bench, an ESP32 microcontroller, which read the raw data and converted it into useful information, a plastic takeout dish, which acted as a chamber, a 3D printed base, which provided an airtight seal, and a home for the electronics. We let a pair decompose inside of our test bench for 30 days and used the sensors to monitor progress. After a 30-day testing period, we compiled results and found an exponential methane production pattern, just like our research had predicted. At the time of this video, we are experimenting with a slice of bread in order to collect a wider range of data. Results of our experiment show that this process is definitely feasible, with 4.6 liters of methane produced, even though the conditions were not optimal. Using this data along with our research, we start working on the next steps and future implications. In the future, the goal of this project was not to do experiments, but to design a project which could be commercially available. The Watt Box, similar to a trash can style container, lets people put food waste inside of it. The decomposition process would begin in a user's location, with the food starting to decay over the 30 to 45-day period it spends with the user. Then it would be collected and taken back to a facility to turn into hydrogen and then electricity. These watt boxes would be purchasable and then delivered to your home, and you would simply put food scraps in and wait until the end of the month for collection.